This is the Amp Hour Podcast. Released October 10th, 2021. Episode 561. Assembly Chat.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics, and I'm assembling a board because I put down solder paste right before we were supposed to record. And I was like, oh, I have to assemble during the Amp Hour. So I was like, all right, I can make this work. This is like you're sitting and you're listening to two coworkers BS in the lab while one of them
is assembling a board. And the other's just annoying the hell out of them while they're trying to do it.
You know. But like, we're okay with it. I mean, yeah.
Right. Yeah. No, of course.
Yeah.
Yep. Okay. So you think this is a good idea. So I assume.
I mean, it might be a bad idea.
Right.
Let's be honest. I mean, we'll find out. I might get really distracted, but maybe no more distracted than when we, are looking on the internet to try and find a link.
Got it.
Throughout the show.
All right. So I assume that you have a PCB in front of you. You have a printout of the overlay. Do you?
Three
do you have
PCBs.
The schematic? Huh?
I have three PCBs.
Three. Okay.
Yeah, I'm three at once. I don't use a printout anymore. I use Interactive Bomb, which is a great
You've got that plug-in for KiCad that does the thingo. Yep. So can you mark them off as you go?
Yes, you can.
Oh, okay.
Yep.
Right. Yep.
Yeah, so that's nice.
Yep.
The really cool thing about it, what I actually found out for a client a while ago, is that it's just it's just I-bombed at HTML, right? So whoever the author of this created this with like JavaScript, and it's just a single file, and so you just double click on it, opens in a browser, whatever. Really cool though. I was like, I wonder if you can, or maybe I actually saw it on Twitter, but I ended up uploading it to my website, and then I put like a Apache, I think it was Apache or Nginx, like one of the web servers, like passwords in front of it. And so basically I had the client's like bomb available, and it's like, it's really cool because you can even, so that they could then go and see it. And this was an open source project anyways. It just wasn't released yet. So they were okay with it.
Okay.
And then you can actually like go through and like see the whole bomb, but even the newer version even has like traces. So you could, in theory, you could go and search for a trace and do troubleshooting like that too. Which is pretty cool. Yeah.
Yeah. Awesome.
Yeah.
Excellent. Just like Paul Daniels' interactive board view thing that
I don't know if I know that one.
Lewis Rossman famously uses it in his videos. He that's how he debugs all the Macintosh computers he actually repairs. He's got this board view software written by Paul Daniels. He's an Australian guy, and he wrote this software to load in all these pirated schematics from Apple, all these, because Apple don't actually
right. It's not like they're handing them out or anything like that.
No, it's not like they're handing those out. Yes, they have leaked out. I think they are official Apple schematics, but they're actually leaked them out.
Yeah, they're verified.
They're actually leaked out. Someone at the factory leaked them out. Right. And anyway, you can get hold of these in various ways. Yeah. So he wrote software, that very cool software that imports the schematic and then overlays it with the board image, and then you troubleshoot, like you actually click on a bit and it highlights the trace that goes all over the board, and you can actually trace it down exactly, So that's how I was able to do very efficient repairs to Apple Macs and stuff. And it's very cool software.
Yeah.
So So if you're in the board repair business, like that would be the essential tool. It's just trying to do troubleshooting with no schematic and no board layout is like not that great. It's like you would eventually get to realize that there's supposed to be 3.3 volts here, but I don't really know what it does, because unless you reverse engineered the whole bloody thing,
Right. Yeah, it would really slow things down, right? You would just be like kind of, or just removing random components, and it would be a bad time.
No, it's having the PCB and schematic is much better. So that's it's cool. Does your tool tell you, like, because really, like, if you've got a bunch of 10K resistors, you want to place those all at once. You don't want to go, one 10K.
That's right.
And then go do another one. Does it tell you where all the one particular part is?
Yeah, I feel like I should just try and upload this while we're talking here. But yeah, it does. It groups them all by component,
Right. Okay.
value, and NPN. Yep. You can basically select it when you generate the bomb.
Okay.
Yep. And I think it works for Eagle too, or it did at one point, or okay. I don't know. I remember it not being just for KiCad. So it is by far like, when I talk about like extensible systems and stuff like that, and I'm excited about like the scripting that's available and the plugin ecosystem, like this is almost always what I'm talking about. I mean, there are other very good examples as well, but like this is just, I don't know. This is something that is like very classy, useful software that just happens to be open source, and like I mean, like Altium must have something like this, right? I don't know what it's like.
It does. I don't know. Well, no, I think it does now. It didn't when I was back at Altium.
Oh, got it. Yeah.
It kind of, well, no, it had like a cross probing thing so that you could cross probe and stuff like that. But I think it might have something like that now, but I don't think it's as good. So don't quote me on that, because I'm 2 versions behind on Altium. So I don't.
Sure. Yeah.
Yep. I just don't use it enough these days. Yep. I don't keep up to date.
So it's pretty cool though. I can also talk through some of the things that I've been finding on this board so I've already gone through. I assembled the first one, did the troubleshooting, and now I'm assembling based on the fixes there. One thing that the part I'm on right now is actually it was a common. I don't know if it's common. You can tell me this, I guess. It was a 10 microfarad capacitor that I had on the board, and I just didn't pay close enough attention to the voltage rating. And I've got a boost converter on this thing that goes up to 24 volts, and I've got 16 volt capacitors. And I was like, well, that's not going to work.
That's going to ruin your day. Yeah,
that's right. Yeah, that's going to go pop, pop, pop.
Yep.
Yeah, pop goes the weasel.
Because most small ceramic capacitors are designed for like low voltage, like 6 or 10 volts, something like that. Like especially the large value ones, right?
Yes. Well, and this is a 1210, so I definitely I knew to go big, but I just didn't I didn't order. I think it was when I actually went to the actual order stage. I either didn't mark it, like in KiCad, it's not tied to the actual library, which some people don't like, and that's fine. But I make that decision when I go to put all the BOM together,
right?
And that did not go properly in this case. It's fixable, but it's like if I didn't catch that, it would have. I didn't burn anything up, but I definitely caught it the last time I was assembling.
Okay, so it actually worked with the 16 volt cap.
No. I'm saying I caught it before.
You caught it before you did it. Okay,
yeah,
right.
Yeah.
And how did you catch it? Because these capacitors don't have any markings on them.
I was worried about it. Was when I was assembling, I was like I was looking at this trace. It was like a big trace for a higher voltage. I guess the high voltage doesn't matter, but it's a power trace. And so I'm like looking at it. I'm like, isn't that going to go to 24 volts? And then I was like looking at tracing it around. Yeah. I also another thing on this too. Like it's a boost converter, but like I'm like staring at this thing, and I have a huge loop, like a feedback loop, to go from the output back through the feedback network to the controller. And I'm like, well, that's wrong. You're supposed to keep that really tight there. And like, it's just, it was not late. I must have laid it out really fast. And
I was going to say, I thought you were the one who designed it and actually laid it out.
I am. Yeah.
Right.
Well, past me though, like, I can blame that guy.
Right. Yeah, of course. Great.
Yeah. So yeah. There you
go. Trap for young players. Are you the type of person who gets anal retentive about which orientation your parts are? Like all of the resistors, all of the values must be in the same orientation.
No, we've talked about because I remember you saying that you like to do that. And I think that's actually really useful when it's assembly time. Usually, and this is such a big board, like this is a sizable board, so it's I definitely have the space for it, but I'm just not in that mode. If you're usually in that mode though, like you're trying to do that, right?
Oh yeah, it's just something that I feel that I don't know. I just want to do it. It's going to be important. Like when you're staring at a board and then you're checking it afterwards, you don't want to have to flip it over 20 times, right? So it's like because when you get the resistors, right, you'll actually peel them off the tape and they'll be on the thing, and you'll pick them up at oddball angles, right?
Yeah,
so it's like so it's very tempting to put it like it's not like I've never done it. So, but it's, if I'm in a real hurry, I will. But, if I got the time, I will make sure it's rotated in the correct orientation so they're all facing the same way so that I can go and just quickly scan the values and make sure they're okay. So,
yeah, that's a good idea. I mean, I don't know. I've gotten into some maybe questionable habits. Like I definitely, I don't do silkscreen anymore. I'm just like,
Right.
yeah, I don't want to.
Right. And is
deal
this
with
a
that.
reflow board?
This is definitely reflow. This is the
Right.
oven that I talked about last time,
Yes, the
or a
oven
couple
we
times
talked about
ago.
last time. Right. Okay. So you've got your paste down, and you're
Yep.
right. Okay.
Yeah, pasting at home. I've used that paste. What's it called? Like the jig, like M Hub, where it used to be. They had like a jig with like, so you have a frame stencil, and it's basically kind of hinged at the back of the
Oh yeah.
stencil,
Yep.
and the whole thing folds down.
And
I find that
then you pull the arm forward, and there's a big squidgy in there that
that's right.
moves the paste over. Yep. Yep.
Yeah, I find that sometimes it's just easier to do with just a non-frame if you're not doing it professionally, like on a machine that the frame stencils are made for.
Yep.
I find sometimes the flexible stencils, especially for small stuff, it's just easier to do that on my own,
simple. Yeah. It's easy. For those who don't know how you do it, you get a blank piece of PCB, and then you just stick your stencil on top, and then sometimes you'll actually line it, you'll line it up properly, but sometimes you don't have to. And then that's the same thickness as the board. That's important to have it flat. And then you put it over, you line it up, and then you just get your credit card or whatever and whack your paste on, and
exactly right.
Yep, straight over.
I took some photos of it. I was like looking at it. I was like, oh, I should probably not put my old credit card numbers
your old credit card
in the
numbers.
shot.
Yeah, right. Okay. Shouldn't matter, but still, yeah, they can track you. Maybe, I don't know.
Yep.
Somehow. Cool.
Yep.
All right. Well, don't sneeze. Don't. What is the smallest part on there?
These are all 0603. So this is, like I said, this is a huge board.
Yep.
And I have just successfully uploaded this. I'm going to try and send it to you. We'll see if I can get this to you in a timely manner so you can see it.
Okay.
I'm not going to share the link with anyone else, but man, my keyboard is too far away from my computer, and so as I'm trying to type my password
I'm surprised that you can even send the link like that other people can view. That's really cool. So that's kind of like a remote working thing.
Yeah, it could be. I mean, if we were like working together on a project, it'd be just as easy to do like a Zoom link or something like that, right? But
right, okay, and then share screen or share video
screen.
Or something
you can
like
mark it up, that sort of thing. So
cool, bananas.
Yeah, it is pretty cool. I mean, like, and it's a little bit more. It depends how wide you want to do it, right? It could be. I could have just sent you the file. That probably is the easiest thing to do. I'm just going to do that real quick.
No, just send me the browser link. That's easy.
Well, I'm trying to do that, but I had to like.
Right.
I'm trying to. I'd have to send it to. I'm trying to send it up to my server right now, and so instead I just sent it to you as a standalone file. Over GChat.
Okay, right, okay.
Yeah. So
I didn't know you could just send it as a HTML.
Yeah, that's the thing. It's like it's all inclusive there, right? It just kind of sits there.
With that, I won't be able to see you interactively live with it.
Yeah, I don't think there's actually a way to do that.
Okay. So you can't do that with the web link. So it's just.
Yeah, I'm not sure you'd need to. I mean, I guess you could. I mean, like otherwise we could do like a screen share and then it would work, right?
Right.
Then you could see what I'm doing as I do that.
I can't. Doesn't automatically open in my browser. That's dumb. What's going on here?
Yeah, you might need me to download it first. I'm not sure.
Yeah, I don't even know how to download it actually.
Oh, maybe it doesn't like it coming through GChat.
Yeah,
like,
save
why are you sending?
as?
Why are you sending someone an HTML file?
Yeah, I know. It sounds dodgy, doesn't it?
Yeah. Right.
No. I think I got it. Okay. Yep, I downloaded it. Yep, there we go. Cool.
Yeah.
Yep, there it is. Yes, cool. Now I can interact with it. Okay, I thought I would be able to see you interacting with it live. Okay, that would have been way too cool.
That would have been cool. I mean, I'm not sure. Actually, I'm not even sure what version I did this with. I don't know if this one actually has the traces. Full screen.
Yes, this I have used
this
before.
Does not have the traces. Yeah, you probably have, right?
Yeah, I've used it before and it's cool. I don't know why it's not integrated in the standard build.
I'm not sure either.
Like it's such a killer thing. I don't know why, it's all open source. I'm sure the author wouldn't mind. I'm sure the author would love that it's integrated in the standard build. Wouldn't they? Surely.
I don't claim to know anything about what motivations are around open source projects,
Right. Yep.
Yeah,
okay,
I think, and sometimes I think it is better to be separate in certain ways, right? I mean, if there's money involved, it might be a little different, right? It was like, oh, you're not paying me enough, but
But then you've got to work out push updates. I don't know how all that works and things like that. I mean, the maintainers of the KiCad build may have a different idea to the author of the plugin, and then they may, I don't know, fork it and go in different directions or something. You know,
might just be easy to
right? So
save feelings, save time, and just do it, do it separately. The only downside is that it's another step for people, but I think we've sufficiently said it's cool enough that people should do it. So,
does your board not have component designators on the silkscreen?
Yeah, that's what I was saying. I stopped doing that.
Sorry. What?
I don't do designators on the board anymore. I just don't. I can't be bothered. For tiny stuff, I'm just like, I don't want.
Wow. No, wrong. What? See,
interesting.
So you don't even put like R10.
No. Yeah.
You wouldn't even.
You
put
thought I was
R10.
talking about values.
No. Both.
Yeah. I think it looks cleaner. I don't think most people need it. It's you could say it's
sorry,
for me.
Nope. That's a thumbs down.
I always have this
me.
open though. No, that's fine. I mean,
Yeah. No, but somebody else.
I am the one who has to use this.
Yeah, but if it's an open source product, if other people are going to repair it and stuff like that, it's nice to have a component designator on it.
Yeah, maybe. Well, you are welcome to submit a pull request, which if people don't know is the open source way of saying, "Oh, bless your heart," or also "Screw you." Yeah,
screw you. I'm going to fix this crap.
Oh no! It's saying if you want to change it, you can feel free to go change it, but in the meantime, you can pound sand.
All right. Wow, not even like I can. Values is a thing. Values is,
I wouldn't do values.
Yeah, no, values is nice if you want to actually have independent people repair it actually down the track. That'd be really nice.
Well, I mean, this is like Apple. I'm like Apple,
Right.
I want someone to make
it's not absolutely essential though. But
yeah. Oh man.
Oh,
no zero ohm resistors here, Dave. What the hell?
Zero ohm resistors. Yep, I'm sure there's a component shortage on zero ohm resistors, is there?
Yeah, no, there's not. But
no, there's not. You can still get zero ohm resistors.
But I was looking at my stack of components, which I'm going to go dig through here in a second. And I was looking at my box of like microcontrollers and sensors and stuff, and I was thinking like, I could make some money right now.
Right. Hoard.
Yeah, hodl the components.
Hodl your components. I'm telling you. Yep. Hodl.
I don't know. I do wonder what that would look like. Like, are people just selling them on eBay? Are people actually selling them, or are we just such pack rats that we're like, no, I'll never do it.
I'm sure there's people selling. I'm sure
my cold dead fingers.
Yeah, exactly. Yep. Well, it depends. If you're making a product, like if you've got a product that you manufacture, you're going to hodl those parts, right? There's no way you're going to sell them to make a quick buck. You're knowing that, geez, these things, I need these things.
Right.
So, yeah.
Liquid gold, black tea.
Texas tea.
Texas tea, that's it.
That's it, Texas tea. Yep.
Yeah. I didn't really watch that show that often.
No, you didn't. No.
Yeah. No.
Even I did.
A little before my time. Yeah, that was that was how you got a picture of Americans.
Right, yeah, exactly. Yeah, that was my entire view of America. Yeah.
That's okay. We have very specific views on Aussies because of the media as well.
Yeah, of course. I know. Yep. Yeah. Shrimp on the Barbie. Yeah.
That's right.
Oh, jeez. All right. Sorry, thumbs down for no component designators on the silk screen. I mean, that's just lazy ass. I mean, for those who can't see, this is a big board. This board is like 10% populated. Like, this is not dense.
It is not.
Right?
This is not dense at all. No,
this is not dense at all. No, this is just. But don't you have to go to the effort to turn those off?
There's a script in KiCad that you can just do everything at once.
Oh, okay. Switch them by. Because I was going to say, if you went to the effort to individually switch each one, or something like that, then that's just dumb, because you might as well spend the time to drag each one. It's no effort to drag a designator. Goodness sake!
Oh man, this is a little judgy, Dave.
I know.
I wasn't sharing. I was sharing this to show you how cool this platform is, not for you to. I wasn't looking for an ad.
You didn't think I'd take you to task on that?
Well,
my
okay.
goodness.
Okay.
Well, then why would you
point to the latest board that you made? That's
why would you even bother?
That's my scoreboard.
Why would you even bother labeling the damn connectors then? RS485.
Well, that's for users.
Power and
I mean,
boot.
most people who use boards are not the people that are repairing boards.
Right,
Most people are software. Well, okay,
Yep.
cards on the table. This is for
Right.
software people. This is
right. Okay.
building this for
Got it.
for other people, right?
Yep.
And so,
Yep.
This is thinking about, they don't really care, and the ones that do
Yep.
care, I don't know.
Yep.
I think they have a little bit more leeway than I do, but I will also point out that Adafruit does not label their components. They have more leeway because
Really?
obviously they make more boards and they're much tighter. So
They don't. No, you're saying no Adafruit boards have component designators on them.
None that I've seen. That doesn't mean none of them do, but I think it's because Limor puts them on a different layer, and so they decided not to do that. I'm not sure why.
A different layer?
Yeah, I think it's like
they're not the kind.
default.
They're not the ones who put them under, like physically on top of the component and then put it on a mechanical layer, are they?
I think it's something like that.
I think
I've only
that's
ever
it.
seen that.
I think that might be it. Yeah, I've seen a lot of projects like that, and it's bloody annoying.
Yeah, it's tough for, like if you're pulling it in. For me, it was confusing because I was like, using their board as a basis. It's all open source, and we love that.
Yep.
And I was using it as a basis for another design. I was like, where? I just couldn't even tell what was what. But also, every time I open Eagle, I'm just so confused about how to manipulate anything.
Right. Well, you're right in that most of their boards are like little.
That's right.
Micro
feather form factor
feather, things like no, and you simply can't add those. So, but that's
they have much more of an excuse than I.
Yeah. Do. Oh yeah. No, totally. But there's no excuse on your board, dude.
Well, I like how it looks. I have to say, the real reason I started doing it is because when I was doing 3D renders, and this is not a good reason, but this is the reason, is it started when I was doing 3D renders and I needed to send stuff to clients. And like I said, most of my clients don't care. I'm the one who has to deal with this stuff. So the actual building and the actual like troubleshooting.
Yeah, but then you can turn it off in the 3D. Oh no, but then I guess you turn. But
I'd
no,
have to turn it back
it's a
on
silkscreen layer, and then you turn off all your labels as well. So
no. So it's in the 3D render, at least in KiCad, in the 3D render, you when you turn off the silkscreen layer, it will still show up in the 3D render unless you go and turn everything off.
Oh, really? Okay, that's
I'm not sure why that
kind
is.
of a bit weird. That sounds a bit
is
weird off the top of my head. Okay.
Yeah, it's jarring because every time you like import a new component, you're like, wait, where did that silkscreen come from? Or every time you think you've turned off the layer in the actual layout, and then you go to the 3D model, you're like, oh my god, where did all that come from? So so that's how it started. And then I was like, well. Then I was making a couple small tight boards, like the ABC board is pretty tight, and I don't know, I was doing 0402 stuff, and it's just, it's easier.
Okay.
So,
can I take you to task again?
Of course. I'm in. We got to talk about something here. Although usually in the lab, when you're like chatting with a buddy, it's a a little friendlier, I got to say.
Yeah, right. Okay. I don't think
more like
you've been to my labs. You haven't been to my labs. Right.
Well, I have been to your lab, and it was very friendly when I was there.
Yeah, but you haven't, been to like where we're actually working on something. Yeah, like you've got this large what looks like a connector in the middle of the board. Like, is that a module or is that a connector?
That is a feather. Actually, it's a feather landing pads for basically a feather form factor dev board, right? So it's basically to make.
So that solders down to the board.
It's a it's a surface mount set of like a 16 pin. 0.1 inch headers, surface mount, and then a 12 pin surface mount headers.
Right. Yep. Why do you have components under it?
So it looks like it's a single component, but it's actually two sides. So I did the silkscreen. So it's like I said, it's a 16 pin and a 12 pin individual headers. And then what really plugs in though is a single board.
Yes, but those components are still under the module, right?
Yeah, but they're like raised up by.
Yeah, they're raised up. That's fine, but I'm talking about access. I'm talking about access for probing.
Let's see what's under there. There's a 1K resistor. There's a 0 ohm resistor.
There's 4 resistors and 2 capacitors.
You can actually select. Can you select in?
3 capacitors, I think. Oh, I'm not. It's not, There's they're large resistors. You've got large resistors.
Oh yeah, 4.7K. Yeah, so those are probably pull-up resistors for I2C. So there's There's three pull-up resistors for I squared C. That doesn't make sense because there would be, one is a pull-up for a button. So 2 pull-ups for I squared C, SCL, and SDA. There's a pull-up for the doot button, not the boot button, but the doot button. People following on Twitter will know that
I saw that, but I have no idea what that means. I'm sure it's an in-joke. Yep.
Yeah, Alex Glow.
Right.
And what else is under there? A 1K Monster Resistor, which I could talk about.
Why are you mixing large format resistors, large size resistors with small size resistors?
The 1Ks is because I was getting lazy and I wanted to route signals through the 1K resistor.
Oh, you wanted to route, right? So you wanted a bigger part. Okay. Yeah,
that's right. Enough. Yeah. So that's like a 1210 1K resistor.
Yes.
And it wasn't going to be like a lot more for that,
All of your 1K resistors are 1210s. Oh, goodness.
That's right. Yeah. Okay. Yeah, because what happened was I routed everything and then I put LEDs. Don't tell anyone of this board I'm working on, but I put secret LEDs on the front of the board. And so I needed to put 1K resistors with every LED.
Yep.
And then route all those traces after the fact. And I was like, oh, I have to redo all this layout. And I was like, no,
right.
I can just put the 1K resistor over top of some of the big traces.
Yeah.
And then that just kind of made it right over.
Okay, fair enough. Yep. I've been there, done that. I
mean, it's just like a sourcing way to get out of it. Yeah. I'm sure 1K resistors are now, 1K 1210 resistors are probably out of stock because why wouldn't they be? But yeah,
Fair enough. Okay.
Yeah.
All right.
Other snafus on this board. So the 1210, sorry, not the 1210, the 12 and the 16 pin surface mount headers I put on here. When you use the surface mount 0.1 inch, they have every other side. And for some reason, I always get it wrong. It's you can't buy left foot forward. So if you see at the end, it's always right foot forward. And for some reason, KiCad has both, even though I've never seen left foot forward. And then I integrated that into this footprint. And so I was left pulling the legs out of
innocent components.
Yeah, exactly.
You
and then
murderer.
180 degrees. I was more like a Victor Frankenstein kind of thing. I was like making a Franken connector for Halloween.
Torturing poor innocent components.
Yep, exactly.
Christopher
pulling the legs.
Gamble.
That's right. Yep. Exactly.
Goodness.
Yeah. Another thing that was going on here. So I was going to put so this is like a agriculture board that I'm building, which I'm sure I'll be able to share at some point. But I wanted to talk about that a little bit too, because I was going to put a solar controller on it, right?
Right.
And
okay. Yeah.
Yeah. Pretty common these days. And then
to charge a battery that powers it.
Yeah, like a lithium ion or something like that.
Right. Okay.
But a tip I learned from, I think, Jeff Kavanaugh. I'm trying to remember. I think that's his name. But he's an Arctic scientist, so he does stuff that goes up into above the Arctic Circle, stuff like that. He's like, look, if anything gets near 0 degrees, you're screwed. Your lithium ion just freezes up.
Yeah.
And it's either going to be broken or it's going to just not charge.
Need a very different battery technology for those sort of environments. Yep.
Yeah, and so what he had recommended was to get a low voltage cell, and then so I think it was like a 6-volt cell, which actually goes up to like 8-9 volts. And then you trickle charge on a 6-volt gel cell. And then that's the input. So instead, I just made this so that this just has, so you see external power input. Dave can see this, everybody else can't.
Yep.
So I just did like a off-the-shelf buck converter that goes up to like 18 volts. It's this like cool little module with like the integrated inductor in there. Again, probably out of stock already, but I have some, so I'm good. And I don't know. I always thought that I was going to put like lithium ions in line and then have chargers, but yeah, the solar stuff, it doesn't matter. In cold, you'd think I would have learned about cold weather environments in the past, but no. Learned it from Jeff.
Cool bananas.
You ever designed for the cold or no?
Yes.
Yeah.
Yes.
Oh, the ocean deep.
Yeah, ocean deep. But we knew it couldn't go below. We knew it couldn't go below 0 degrees. Well, no. Technically, we could. Technically, seawater can go below 0 degrees because its freezing point is not 0. Yeah. Its freezing point isn't 0. So, yep. Yep.
That's interesting. Huh. I guess you'd have internal heat from the electronics though too, right?
Not necessarily. So, but you can get lithium primary batteries that are very good at lower temps. So,
okay. Yeah, and that's the thing. Like, I could probably go out and try and find something like that too, but for this kind of thing, and the last time I was doing this, it just wasn't necessary. It wasn't like something that I had the resources and or time and or inclination to do. So instead I switched to this. Yeah. But I had never experienced that before, so maybe if someone out there's listening is like, oh yeah, I live in Minnesota.
Right, yeah, of course.
I live in Norway. But I'd love to hear other like weather-based stuff like that too, because like solar is just like I feel like solar and a battery is always kind of the solution I see, and sometimes it's just not gonna work.
Right.
So
yep. Now I was confused when I got a European car.
Mm-hmm.
It came with a battery warmer cover.
Yeah.
It came with like a little fur coat around the battery, and I go, "What the hell is this? What why?"
Yeah.
I just like.
Is there air conditioning inside this coat?
No, it's just a little fur coat around the battery to keep it warm from freezing in the middle of winter, and it's like, not really needed in Australia. So
No.
Yes.
Yeah.
Anyway. So if you want to know about lithium primary batteries, they can go down to minus 55. So,
really?
Yeah.
Oh.
Yeah. Yep.
Huh. That's really pretty cool.
Yeah. So you can't just
they're not
say
going to charge though, so because they're primaries, right? So
they're primary batteries. Yes.
Yeah.
So So there you go. So yes, it's not like you can't just say, "Oh, lithium batteries don't work at zero." That's just not.
Oh, I see what you mean. Yeah, no, I meant the charging. I mean, the charging was the main thing, but yeah, this is not a particularly battery optimized thing either.
Right.
There's a RS485 on here, and 420 controllers, and just it's not. This is more industrial than anything, so it's not going to be. This is not going to win any low power SIPI awards anytime soon.
Right. Anyway, the one I was talking about was a lithium Thional chloride battery. So you can get those to go down to.
That sounds like
very low
very toxic.
Well, it's a lithium inorganic battery, I think they call
it.
Inorganic battery.
What does that mean?
So it's some to do with the thionyl chloride. I don't know. You got to know your chemistry.
Anything organic is going to die if it touches thionyl, whatever.
Right. Yeah, exactly. So, yeah. But, as I looked at in one of my videos for like a 30-year battery life multimeter or something I did a video on. And it was like, you can get batteries that last for, have a shelf life of like, exceeding a decade, well exceeding a decade,
Mm-hmm.
So, yeah.
Yeah, I think about some of the stuff that's out there these days, though. Like, probably the most likely thing that's going to kill stuff these days is not like, I mean, even if it's super battery optimized, it's like, all right, is it getting firmware updates?
Yeah, right.
If it's talking to the network, is it still going to be able to talk to the network? Is the network still there? Like, I don't know.
Is the network still there? Speaking of which, yes, Facebook, they completely kamikatze. Right, so some idiot, I don't know, pushed the wrong button on the network update and it just nuked the entire presence of Facebook. I didn't notice because I don't use bloody Facebook. So
I did just because I was laughing at it all day.
Right, it was great. But anyway, the funniest thing that we both thought was the funniest aspect was not that it vanished from the internet. Whatever. It was the fact that they couldn't access their own server rooms because their security, key swipey card security system was controlled on Facebook servers.
Yeah.
So
I thought it was building access, but
building access. Yeah, but I heard it was like the server room or something. So I don't know.
Got it.
Yeah. Yep. So why?
Yeah, I mean it's like one of those like systemic things, like everything's connected. It's all great until it's not, Like...
Yep. It's like it's like if you design your own swipe access thing for your home, and then it's controlled via the controller, which is inside your house. It's like, if it goes down, then you can't get inside to even fix it because like, it's just dumb. Right. Yeah. Right. And you
don't worry though. It's like that back window just pops right out. I have a really good security system, but then the back window pops out.
Right. Everyone, Chris Gammel's house, free to.
Yeah. Right. No, not this house. Different house. That was that happened to me.
You want some feedback on that sort of stuff? Do a video on I did a video my lab, my new storage unit downstairs, how I put a new lock on it, right? I changed it to a lock to match my bunker. You've been to my bunker here. It's a similar sort of thing downstairs in this building. And yeah, I've got like the world's most secure key on it, right? It's a Abloy.
Really?
It's an Abloy Protect 2, and it was unpickable at one point, but there are a few people in the world who can pick it.
There's a thing called the most secure key. That's weird to me. Like that. That seems odd.
And no, but anyway, it is one of the most unpickable locks out there, right? Huh. So it's like Joe Average locksmith cannot pick this thing, right?
Oh, interesting.
Like if you call up a locksmith and say, please, pick it, they'll have to find some other way in because they can't.
Yeah, I was going to say, don't most locksmiths just drill the lock anyways?
They would have to drill the lock, or they'd have to get in some other way, right?
Stick of dynamite.
Shimmy, or they'd have to go do an attack under the door or whatever. And so I did this video challenging the lockpicking lawyer, right? Who's a hyper, he's like the biggest. You might have seen his videos pop up. Anyway, he's like the biggest lockpicking. He's the biggest lockpicking YouTuber out there. And so I did a video sort of like challenging him, because I actually challenged him 2 or 3 years ago to, I bet you can't pick this lock. And he said, I can pick any lock. And I said, it's an Abloy Protect 2. And he said, oh yeah, that's one I can't pick yet. And 3 years later, I'm still waiting for him to pick it, So anyway, so I released the video, so it's just like a tongue-in-cheek thing. I was just, and then everyone gets in the comments and go, it doesn't matter how secure your lock is. You can drill it, you can smash it, you can shimmy it, you can do underdoor attacks, blah, 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 oh God. Okay.
Yeah.
Yeah. Welcome to the internet.
Is this like, I was going to say, is this like a common thing people know? I have no, I mean, like my solution is to call a locksmith, I think.
Right. So. Okay. Yeah. No. So yeah, anyway,
brick through the window,
you can't, the whole idea is that this is an incredibly difficult lock to pick, but yes, you can just smash the door in, fine, Yeah, you got me. I'm owned. Ugh, you can see, I don't know if you can see my eyes rolling in the back of my head now.
Got it. Yeah.
Right.
I mean, locks and computer security and everything else, right? It's just to slow people down, right?
Yeah, it's dumb if the controller's in the... I think it's dumb if it's going back to any central server. If you've got Internet of Things connected anything and it fails, well, it's your own fault for using Internet of Connected Things. It's like, it's dumb. No, if you're going to have a house alarm, just make it standalone. They're super duper reliable. They've been engineered to be, incredible. Although, granted, my one blew up.
What?
I have to link in the video. My local NES unit, which is a company here in Sydney, who actually designs and manufactures alarm panels. They're one of the biggest I think they are the biggest in Australia.
You're saying NES or Nest?
NES
with a T.
NES.
Okay.
NESS. Yes.
Yeah.
Sorry.
Got it.
As opposed to that ridiculous Yankee thing, startup thing.
Yeah. Well, not startup anymore.
Which is now owned by Google, isn't it?
Yeah, I just say Google,
yeah. Anyway, so I hope Google headquarters, Google servers are all protected by Nest access systems, Nest access control. That'd be, and then their own servers.
Well, it's mostly like, it started with thermostats, but now it's like,
it started with
Home.
thermostats, and then it branched out into cameras and whatnot, and, all sorts of things. Anyway, where was I? Yes. My alarm panel blew up because the capacitor on there, a little ceramic jobby, was across the power supply and it smoked. It just went short.
Huh.
Yeah, it caught on fire. Big Ernie Bernie marks everywhere.
Oh, wow.
Yeah, so my panel failed. These ultra reliable panels. So, yep.
Not that reliable, I guess.
Not that reliable. They should have put 2 capacitors in series, would have solved that problem. That's how, if you want to design reliable electronics, that's one of the tricks, because ceramic capacitors done a whole, probably multiple videos on this, how they can crack, how they can get micro cracks, and one of their failure modes is short circuit, right? It's one thing for a capacitor to fail open circuit, but it's another thing for it to fail short circuit when it's across your power rail. And most capacitors are across power rails, right? Mm-hmm. So if you want to make an ultra reliable circuit, you put 2 capacitors in series. Sure, you halve your capacitance, but if one of them fails short, the other one's there and it just acts like a regular cap. In fact, you've still got capacitance on your rail in that case. So if you're designing ultra reliable circuitry, every capacitor in series, 2 of them in series.
Yeah.
Across every decoupling capacitor, 2 in series.
Interesting. Yeah. Well, there's another.
Yep.
There's another thing for my board.
There's a pro tip
Yeah.
for you.
Yeah.
Because like it's rare that it happens, but it does happen, right? And
yeah.
So anyway, yep. So there you go. Tip of the week.
Yeah.
Capacitors in series. Yeah,
it's
the best. It's the best of the both worlds. Like if one fails, you still got half your capacitance there, so you're still doing half your decoupling or filtering job. Which is still probably going to work, right? Because if you engineer your product,
would you do that on every product? I think. I mean, that just seems like not wasteful.
No, you wouldn't do it on every product.
But like you're saying, like high vibration, maybe.
Definitely any high vibration shock,
just high reliability type stuff.
High reliability product. Yep.
Because I mean, I would imagine that maybe a security industry type thing, it would be like, oh, well, this needs to never ever fail. You could say it like that, but
like you don't need to, because you can actually buy specific capacitors that are designed for this. They're either designed to fail open, or they've actually got. This was in my video as well. You can actually get components that have little flexible end caps on them. So that they take out the shock and vibration. It decouples the shock and vibration that comes through your board into the ceramic plates inside, and it decouples them. So then they're not going to crack or whatever. And you'll pay 10 times the price for them. But if you're designing a high reliability airbag controller in your car or something, you're going to be using those caps because they're automotive grade and they're but you're paying 10 times the price for them, right?
That's right, folks. Dave says, design in hard to get components. It'll be fine. What could possibly go wrong in 2021?
Unfortunately, you have to.
Yes, that is correct.
Yeah. In certain industries, to meet certain specs, you have to. Yeah. Like you can't just, I'm going to get this capacitor from the Shenzhen market and I'm going to whack it across my power rail inside my car airbag. It's like, no, you're not. No, you're not.
I don't know. I feel like that's one of those things where it isn't really going to get put into place until something goes wrong. It's like until it's like in a lesson learned thing in a company's books.
Totally. Yep.
It's unfortunate, but so wait, did you expect that they would do that in this security panel?
No.
Okay.
No, of course not.
I just wouldn't think that would be something that would.
No, because these aren't in a high, they're like placed there once and they sit there forever. Like they never move, they're never touched.
You're not in Japan, you're not getting like actual like vibrational stuff, right?
Yeah, no, they're permanently powered up, they're just powered up forever. It isn't like they're even power cycled,
Right.
So it's Yep. So, but with hindsight, having that cap across the main power input and caught on fire. But then again, like a failure in something like that is not critical, right? Yeah, sure, your alarm panel breaks, you don't have your alarm, but it's not gonna, it doesn't impact anything, right?
The likelihood that it's breaking as someone is breaking into your house.
As someone is breaking, right.
Low.
Yeah. In fact, it probably doesn't matter. The fact that you've visibly got an alarm system is something that actually deters.
The most important thing in an alarm system is the little placard that's out in the garden
is
out
the
front.
little sticker out the front. That's why you can just buy the sticker that goes on your front window that says this, things,
This house
this
protected
house
by
is alarmed by shotgun.
Killer drones.
Drones and shotguns, and especially in America. Yeah.
South.
Anyway.
Well, on the security side of things,
Yep.
Past guest Josh Dadko has been, as people will recall, Josh is a bit of a talker. That's the thing we love about him. He was the one who was telling all the submarine stories, if people don't remember. But he's been doing security consulting, and he did a video a couple weeks ago. He's been posting them on LinkedIn mostly, and so you can follow him there. But he posted about like security risk and like IoT, like security audits and stuff like that. That's kind of something he does now. Yep. And he pointed out something I had never heard about. I've actually been asked before, like, you think about security for a device, for a product rather, like where do you go to find this stuff out? You can go hire someone like Josh, but he talks about this thing called the OWASP 10 top 10. And so this is something called I'll send you a link here actually. The OWASP top 10 is like security vulnerabilities for like anyone's hardware. And it could also be, it doesn't have to just be connected.
Is it like an independent rating thing, or is it what is it?
I think there is like a way that products get rated, but this is really more about like just the things that are most likely to break down, something that's going to break down a system. So like attack vectors that are common in bad IoT devices, I guess.
Okay.
And some of them are like completely obvious. Actually, can I send you this link? Yeah, some of them are completely obvious, like bad passwords, hard-coded passwords.
Yeah, right.
You know,
okay,
like,
yeah, of course.
Okay,
Of course.
yeah. No one's surprised by that one. But like not being able to update, so if it is a connected device, if it's not able to like update firmware, so like you have a thing, you've deployed 100,000 of them, and even if you wanted to, you couldn't probably go and find all of them and get them all updated. So now this like thing is out in the middle of the world, and it's this big vulnerability. Like,
but also the remote updating is a vulnerability in itself. The ability to remote update something, that's also a vulnerability.
Yeah.
So,
is that I don't think that's listed on here, but
but bloody well should be.
I do agree with that.
Yeah, right.
Yeah. Use of insecure or outdated components. That one's interesting. That's a hardware one. Like if you have like a, I guess if there's like a crypto engine that's.
Yep. That's been attacked or hacked or whatever, and then you're still using that chip in your product. Yeah,
exactly.
Right.
Like a known that lock has already been picked many times, sort of thing.
Right.
Yeah.
Insufficient privacy protection. Insecure data transfer and storage, lack of device management, insecure default settings. Yes, default settings on routers and stuff like that. They just leave them there.
Admin
or
password.
The password is God.
Oh yeah, classic.
Right.
Yeah. 25 years now that movie has been out. Did you know that? It had a 25th anniversary for hackers.
Right.
Still as good as the first time I watched it, Dave.
Yep. Right. Excellent.
Yeah. Classic.
Come on, you only watched it for Angelina Jolie, didn't you? That was it. That's the only reason.
That's the reason I got into computers in the first place.
Right. Okay. Yeah. Right.
No, man, it's a classic movie.
Yeah.
Not the planet. Not the planet.
Yeah. Okay, I'm going to have to watch it again. Yep.
Yeah, I mean, you have to now, right?
Yep.
It's so bad. It's so good.
Yeah. I know.
Yeah.
I think I only saw it a couple of years ago. Again.
Oh, really? Oh, okay.
Yeah, it's relatively recent that I watched it again. It popped up on Netflix. I was bored.
Totally.
Like that,
Yeah.
Yep. There you go. All right. Something that's really cool. This
amp hour thing is really slowing me down. Just so we're clear.
Oh, okay. Just so we know.
Really
okay. Well, let's.
Here,
Okay. Well, you get on with it, and I'll yap away in the background.
Okay.
One thing I really like from the list this week is the analog thing. So
I think we talked about that once before, but I think we mentioned it, but I don't think we dug into it.
Really? Oh, okay.
Yeah.
It's very. I'm looking at it. It's only coming soon, so presumably you can't buy it yet. But it's an analog computer. It's a modern analog computer with like a big punch panel, like a big connection panel on the front. It looks like a for those who want to visualize it, it looks like an analog audio mixer kind of thing. It looks like
sliders and stuff like that.
Might do something audio. It's got all these knobs on it. It's got a single LCD on it. And then it's just got this big patch panel above it. But I just think it looks really funky.
Yeah.
And it's analog computing because you can learn stuff about analog computing.
Yeah,
it's a cutting edge analog computer.
Is the idea you dig into the hood though? Like, are people going to get their hands dirty with like an op amp with this thing?
Yeah, it's got 5 integrators, 4 summers, 2 comparators.
I don't doubt what it has. I mean, it has that stuff, but I mean, is the point to actually open it up?
8 coefficient potentiometers. I mean, come on, two multipliers. This is great.
This sounds like this is halfway to the
Yep.
What's that fake machine, the confabulator or whatever it's called?
No, I don't. No.
It's that classic video about like explaining like crazy components that are not real.
Oh, the turbo encabulator.
Turbo encabulator. That was pretty close.
Encabulator. Yes. Yeah. The retro encabulator. That and there's one. There's all sorts of variants.
Daniel from Keysight just remade it.
Daniel from Keysight did that.
Yeah.
Retro. Yeah. The turbo encabulator is the main. But before that, there was the just the encabulator, and then the turbo encabulator was an improvement on that. It started in like the 1940s or something. It's actually old. It's actually, it's an old meme. It's a really
old gag.
It's an old gag from like really early on. So I think I'm sure the original people who founded it are way dead. They're like way gone. It's that old. Like,
got it.
Anyway, yeah, it's a great joke. Turbo encabulator. No, this is
so
cool.
Analog computers. Though, have you ever used one? I've never used one before, so I don't even know. What it would be like.
I've never used. No, I've never used one. I've got to admit, I've used some of the concepts, but I've never.
I have too. Op amps are. That's where op amps come from.
Yes. But no, as far as no. So, it's a very niche market. I mean, they're not going to sell 1 million of them. But as with all these things, it's in the value's in the documentation, right? The value's in the actual examples that and the information. I would presume it comes with some booklet or something that explains the concepts and everything. That's where the value is. The value isn't in the product itself. The value is in how they present the information and how they teach you about analog computers.
Well, and if there's community that develops around it too, that's also nice if you get other people to learn alongside, that sort of thing.
Yeah.
If you'll excuse me for 1 second, I am picking a stack of components off the floor right now.
All right, well,
I can't find my 100K resistors.
I shall continue. Anyway, that's very cool. We will link that in. It's from Anna Bird Electronics. The web address is the analog thing with hyphens in there. So yeah, that's cool. And I presume you can pre-order. It's not going to be. I presume it's not going to be cheap.
Oh, I thought I saw it $500 or something. I thought there was a price.
No, I would not expect it to be cheap. It's just like it's a really large thing. It's a really large board, and it's complexly. That is a word. I'm running with it. Complexly put together. And all the documentation and everything that goes into it. So that's very cool. Another retro thing which I want. I discovered this in an old magazine from the 1980s, and damn it, I want one just because it's such an oddity. It is a digital multimeter that only has a bar graph.
Ooh.
That's it. There's no segments, none of that segment rubbish.
Like no labeling or anything either?
No labeling. It's just got a 128 point bar graph on it. And then it's got a zoom mode. So if you want more detail, you can zoom in and it times it by 10. So it goes in and you can actually narrow down your reading and stuff like that. So it was designed as a, it was advertised as the best of both worlds.
So is it meant to be like a digital version of an analog
of an analog meter? It's exactly what it's supposed to do. Let me read it out. This is the ad. The best of both worlds. Analog digital display. Digital multimeters are great. No misreading, no parallax error, high accuracy. But many users don't like the loss of dynamics. Hang on, I'll send it. I'll send
just see the in between. That's kind of the idea, to see as the needle's moving.
Yep. Hang on.
I can't imagine the update rate was that fast on this sort of thing though either.
Hang on. I'm getting there. Oh yeah, there we go. You've got it. Yeah.
Okay.
So, yep. There you go. So it's here's the answer. They say. Oh, sorry. Yes, many users don't like the loss of dynamics because DMM samples at a fixed time interval changing values in a circuit are often lost. Here's the answer. A digital multimeter which displays in bar graph form. 105-step bar graph gives 1% resolution with a fast 10-second sampling, which is actually pretty quick.
I think you should make a 1980s style. I mean, I know this is much later than the 80s, right? Or earlier than the 80s. When was this? 80s? Or
1987, 88.
Oh, man. You should put on, leg warmers and, headbands and, a bunch of neon stuff and, record an ad for this thing. That's what you should do.
As I'm doing my aerobics, jazzercise aerobics. Yeah.
I just wanted to take a break from this to tell you all about the analog DMM that's out there.
It's the best of both worlds, and it's
the best of both worlds.
Yep.
I could be working out with friends or in the lab.
Anyway, I think it is such an obscure thing. Obviously, it wasn't a success. Otherwise, everyone would be going, "Oh yeah, I had one of those." But yeah. Anyway,
have you searched on eBay? Or do these things still exist?
Yeah, no, I've searched. Apparently, it was manufactured by SOAR, SOAR, which was a manufacturer of multimeters in the 80s, which was the first digital meter which I actually owned. Actually, was a SOAR digital multimeter, which I just showed in my recent Fluke 23 repair video. There's part 2. That's my latest video.
I watched the part 2 with I like you took the back off and then you put aluminum foil behind.
I put aluminum. Alfoil.
Alfoil.
Aluminium.
Alfoil sounds like it's Al Bundy's cousin or something.
Right, Al Bundy's cousin. Yeah, okay. Oh boy. Yep. Hey, pig. Sorry. That was a funny show. And yeah. Anyway, I think it's very cool. So yeah, it was manufactured by Saw, but it was sold in Australia by Tricky Dick Smith. It was their branded meter.
Yeah, this doesn't look like there. I mean, there's like 4 buttons on it. What are the buttons? That's the zoom. Is that the idea?
There was zoom. There's a max button, so it had like a min max mode or a max mode.
There's a resistance mode too. Okay,
yep.
I see. Yeah. Right. Okay.
Yeah.
So I don't think this would have been up to snuff to modern standards, I have to say.
Right. Well, it's come on, it's the best of both worlds, dude.
It is the best of both worlds. I feel like you could just make a modern one, and like you could go and program like a Arduino or similar, right?
Yeah, I got to say that 10 times per second updating was, it's pretty quick. It's not as fast as like typically 30 times per second that they have on the bar graphs these days, but they are 105 segments.
Well, yeah.
I mean, with magnification. Thank you very much.
You could also do it like a QVC commercial, and have like the one person in the corner being like, "Oh, 10x amplification. I would pay 10x for that." It's a lot of like it's meme type things you could do here, man.
Yeah. Anyway, I definitely I want one. If you've got one, I will pay.
Dave will buy it off. He'll pay 10x the price you paid, $79.95.
Right.
It was the list price.
I'll pay $799 for it.
Oh boy, yeah, that would be dedication.
Yep. And I can get a whole $50 back in Google ad revenue. Yeah.
Yeah. Right.
Yeah, right. Anyway, I just think, like nobody remembers this. It's like, it's just this obscure thing. And then there's a lot of people, here you go, I'll send you this. There's a lot of people who thought it was like an April Fool's joke, right?
Yep.
Which was fair enough. I will, there you go. I will send you, because the ad doesn't have a real photo. The ad actually has just a sketch of it. It just actually has a sketch, right? Yeah, so this was the original full page ad that I saw, and it's just a sketch. And a lot of people thought, because like they didn't have a real product. That's an April Fool's joke, but it wasn't. It was in the November issue.
That's just how they used to do graphics.
That's how they used to do ads.
Yeah. Right.
Yeah, they would actually draw them. Somebody would actually redraw them because it was cheaper than embedding a photo, I guess, in the typeset machine.
Yeah.
Or whatever. I don't know. They had an artist inside. They had an in-house artist that just redrew.
Right. They were probably doing the layout by hand, right? I mean, they were doing like magazine layout.
Yeah, it's all typeset and cut and pasted and
Yep.
Update
around here. My 40.2 kilo ohm baggie, apparently I swapped out for 100K. That was a lucky find.
Oh,
wow. I did a bad job of that last time I did the assembly here.
So what, you labeled it wrong or you put them on wrong?
No, I put the strip of resistors back into the wrong baggie.
Into the wrong bag. Okay.
Yeah.
So did you notice that because the markings are on them?
Nope. No, these are just still too small. Are these have markings?
Okay. No, they don't.
No, my old eyes. So they still do, but it's because...
Hang on, are you complaining about your eyes?
I am, yeah.
You're getting old. You're married with kids, and you're now complaining about the eyesight. Yeah.
Kids these days with with their fancy eyeballs.
Yep.
Yeah. No, the 100K bag had caps in it, so I knew something was wrong there, and that's why I was trying to find the baggie off the floor. Obviously, the 100K was not capacitors, and then. I was testing the I was trying to find the 100K. I had found a strip on the floor. This is really exciting radio, by the way. 100K strip was on the floor. That had 40K resistors. I used my 121 GW DMM to test the resistance on them. So I knew the 40.2K was out of place. And then when I got to that baggie, I was like, I bet these are 100Ks. And I was right. So
there you go.
Past me was a little sloppy, I got to say. That would have been one of those failures too, where it would have been like, something's wrong here, but I don't know. Like it would have been, it was actually the 40K was in the feedback network of a different regulator. So that would have just been the wrong value, it just would have been like, nope, I'm outputting half a volt. You're not getting any more than that.
So
lucky find.
how many components have you placed in an hour? What is your placement rate per hour?
Oh, really slow. I mean, like
really slow.
I find I do best when I can just like turn on a podcast, not be on a podcast. That's a different part of the brain. Turn on a podcast and just like turn into a the meat picking place. That's what's necessary, I think.
Right.
I'm probably at it's pathetically low. 50 components.
Okay. All right.
I don't know. 0603, so not like not the smallest, not the biggest.
Yep. So you place them with tweezers. Obviously, you don't have a
I don't
suction.
Some people like the vacuum pickup thing. Do you do that?
No, I just use.
When's the last time you assembled a board? You need to make a board, my friend.
I need to make.
You need to join me in my complaining about my old eyes.
It has been a while. Yep.
Yeah.
Yep.
We got to brainstorm. What can you build? What do you want to build?
Because I love. I would love to build something that's just like huge, like a huge board, like a physically huge board that's got
the one that Eric Schlepfer did, the MOS 6502,
the Monster 6502, or whatever it's called. There's something therapeutic about assembling a board like that. It's almost like going and like doing a puzzle. Well, it is like doing a puzzle, but it's like an actual jigsaw puzzle. No, the thing I hate is random boards that have 100 different components on them. They're just a pain in the ass. They're just no, I just don't enjoy assembling boards like that. But if the board's got nice symmetrical arrays on it, or some nice symmetrical blocks on it, or something like that, and I can just do the same value over and over, that's just there's something satisfying about that.
Did I tell you about that? There's a craft that I did. It was last winter, so I may have mentioned it on here. But my wife had bought it. We were on a vacation and in the middle of nowhere, and it was cold, and we were like, well, we could just do this. It's like a puzzle.
Yep.
And it was this craft she had found, and it was these little jewels, and then you get a straw and a piece. So the straw you stick into a piece of putty, and so the putty kind of sticks in the end of the straw.
Yeah.
And so then you use that to basically pick up a gem, and then you place it by, it's like a match by color, and you place it onto the color that is associated with it. And then the thing you're placing it, it's like a sticky mat basically. So it holds the gem. So basically you're picking it up with a little sticky end, and you're putting it onto a sticky sheet of paper by color. And halfway through, I'm like, am I doing pick and place on vacation?
Yeah.
It was very therapeutic, and I think it's a Japanese thing, maybe Chinese. Okay, I'm not sure. It was pretty fun though, as a craft for doing with kids too. I'm not little kids would have a lot of problem with it because it's a very dexterous
manual dexterity thing. Yeah,
right. But if you had your oldest is 8 now, or he's
10.
10. Oh yeah,
yeah.
So you could basically start him on this,
yeah,
and then be hey, by the way,
exactly.
I have a board. This is pretty much the same thing. We're just gonna use resistors now.
Cool.
You got to train the child labor at some point, right? Yeah. So
speaking of 10-year-old kids.
Okay. Yeah.
We will finish off with this. This was my task yesterday. I actually did a live 1-hour physics demonstration with to year 5 students who are 10 or 11 years old. Kids, and so a whole school worth of year 5 kids were all watching me live demonstrate.
Didn't get pelted with tomatoes or anything like that?
No,
was it digital, so you were all safe?
It was all digital, so I was able to dodge them easily. So I had to try and hold the interest of 10-year-olds for an hour doing experiments in physics.
Non-trivial task.
Different forces. It was about this was about forces. So tension and elastic forces and gravity and
that's awesome.
Buoyancy forces, floating buoyancy and all these different types of forces. So I came up with all these little demos that explained it all to them, and I think it was a hit. I think I blew some minds.
That's great. Man, physics is what got me that I didn't get into electronics until college, and but physics was the gateway drug for me.
Right. Okay.
Yeah. Yep. Well, obviously not the forces stuff, but you get if you're into the forces stuff, and then you're like, oh, by the way, now we're going to talk about electrons. Cool.
Yep. No, I think I really blew their minds when at the end I showed them how that their watch can speed up or slow down if you just turn it over, if you flip it over.
And you're like, kids, you may also have heard this on the amp hour. We also discussed on the amp hour.
Yes.
That's great.
But yeah, I thought, anyway.
Do they call it physics at that age? Like, how do they organize?
Oh, well,
science?
no, it's a unit of inquiry. It's like just basic. Like they just touch on it. Like they don't learn the physics formulas and stuff. They just sort of like touch on the concepts. It's not really about learning, like they don't learn like the buoyancy formula, and they don't learn, stuff like that. It's
almost like it's like an overview so that they can see the experiment.
It's an overview concept, so it's in their head. So when they come to learn it in high school, it's sort of, it sort of pops out of their head. That's the, that's the kind of thing. So
I mean, even in high school, when I did it, it was when I did physics in high school, I did AP physics, and it was non-calculus based.
Right. Yep.
So like no derivatives, no integrals,
right.
which is kind of crazy because that's a lot of physics.
Well, yeah, exactly. But you can do some great concept stuff without any of that. You can
true. I mean, and I think that's what it's really about, especially at that age too. It's just like experiments and getting people excited about it. It's like,
exactly.
I mean, hell, that's still the thing, man. I still want to see experiments and get excited about physics. Like, it's so cool.
Yeah.
That's great.
So anyway, one of the things I learned is that, geez, I wouldn't want to be a teacher. Like imagine having to come up with this stuff every day.
I can't even imagine.
You've got the syllabus, because they basically gave me the syllabus, right? The syllabus is like kind of like the semi-official thing that they're supposed to follow.
I'm just imagining like a teacher handing you a syllabus, like being like, you do it, and then pulling a flask out of their pocket.
That's pretty much what it was. I was roped into it because they knew who I am and they knew what I do. And they went, So I think I'm roped into 2 more.
It's great.
So, yeah. Anyway.
That's super fun, man.
Yeah.
I think you should do a reprise version on EV Blog too. I'd watch it.
There is actually, I haven't released it. I actually did. I did actually shoot the video. Yes, it is actually patrons only video. One of them is patrons and supporters only. Is you can see me
support EV Blog.
The full 30-minute dry run test of it.
Oh,
and
cool.
Sort of So I actually recorded a dry run test. Obviously, I can't release the one that was on the day because it includes kids, so I can't.
Well, and also all the IP that I'm sure that you generated that, like that belongs to the school now.
Right. Anyway, no, I
fronted
did
you so much cash, I'm sure.
Although I did release publicly on my second channel, I did actually release last night a video segment from that 1 hour live show. I just chopped out the kids' voices and names.
Yeah.
So
Yep. That's good.
So anyway,
that's super fun.
My second channel. Yeah, so that was fun.
That's great.
Yep.
There you go. But another career, get yourself a real job, Dave. Come on.
Get myself a real job. Yeah, I'll become a teacher,
Yeah.
But there's a lot of people that say that. Why don't I become a teacher? I'm such a good teacher. It's like, well, technically I was. I did actually I was accepted for a teaching job once.
Oh, really?
A long time ago, yes. Long time ago. I was probably 22 or something, and I went for a teaching job to teach PCB design and layout, and I was accepted.
Yeah.
They actually said, I was surprised they gave it to me. Maybe I was the only one who showed up.
I'm surprised they didn't just hire you to critique people's boards about their silkscreen.
Critique people's boards. Anyway, so but then just after, like, I was about to teach it, but then I got another job, I think, and something. It conflicted or something, and I couldn't do it, so I had to.
I was like, I want to make money someday, so probably not going to be a teacher.
Turn them down. So that was my But technically, yes, I was accepted as a teacher at a local college.
Great.
So
that's great.
Teach PCB layout and design. Anyway, the answer to that question is no, I wouldn't do it because I see more value in making content for tens of thousands or hundreds of thousands of people for a broader audience. I see more value in that than just, teaching 50 or 100 people at once.
Also, Dave swears a lot, so not really not a good teacher for kids.
I'm not great. No. And they ask me, what is your YouTube channel? I'm going, it's the EV blog, but I don't really want you to watch it because it's not really, for 10-year-old kids, it's kind of, Oh boy.
Oh, well. They'll figure it out.
Yep.
I think they could probably search and find it. So I'm
sure they can search it. I'm not going to say like, but there's the occasional video they'd see that's probably not suitable for kids, but anyway.
Right.
Yep.
They probably can't find that anywhere else on the internet either.
No, right.
One of my college buddies is he's doing middle school technology stuff, and we were emailing back and forth about just some of the tools that are out there. He's going to be doing some. I think he said he was not CircuitPython. He's using. I always get these backwards. Yeah, no, he's using CircuitPython, which is the Adafruit one, not MicroPython.
Right. All right.
And just some of the tools with that, and like the stuff he's doing though, he's like, yeah, we're gonna do motors and write Python, and I was just like,
yeah, cool.
Man, I wish Charlie was my teacher. Like that would be so
we had nothing
cool.
like that when I was a kid. No,
man, there's other platforms like that. There's like the Lego stuff that's out there these days, like the what's it called, the Lego League, something like that. No. Do they have stuff like that in Australia? Has it made does First down in Australia?
Yeah. Oh, yeah. Yes. I was a judge. I was a judge in one of those.
Yeah.
Yeah.
Yeah. I mean that stuff. I think it did exist when I was in high school because one of my buddies did it, and now he's a dentist. Come on, jeez.
Yeah, I know.
Dan. Right. Yeah.
And failure in life, becoming a dentist. What a loser.
what a rich handsome loser.
Yeah, exactly. Oh boy.
Yeah, but Dan had done first robotics and stuff like that.
Yep.
Maybe it was even at my school. I didn't know about it. It's like one of those things if you're not exposed to it. But it's gotten a lot bigger.
High school was like the opposite of that.
Yeah.
It was like telling me to go away when I wanted to do something like that. It was like,
well, it's not cheap. That's the thing. Like you need to really you need to fundraise, you need to have sponsors and stuff like that.
Yeah, but I was going to do everything and they still wouldn't support me. There was this contest I wanted to enter.
Hey kids, go play football.
There was this
Australian rules because we're in Australia. Sorry.
There was this design contest that I wanted to enter. It was in one of the magazines, right? But you had to have your school sponsor you. Like you had to enter it. Like your school had to okay it or something. Like the school had to support it or something, right? So I was going to enter this contest, and so I went to them and showed them the article and saying, enter the school. All you've got to do is like, I don't know, sign here and support me or something. I don't know, and like not with money or equipment or anything. I've got all the gear. I'll build my own thing. Sure. And they went, no, what is this? Go away, kid. It was like.
And you gave up there? Bastard. Come on, Dave. Go around.
Unfortunately, you can't. That was the one of the firm requirements.
You talked to like the principal though. I mean, you
no, a science teacher and my regular teacher and others.
Got to go higher. Like, superintendent. Super Nintendo Chalmers. You got to talk to the top, man. Right. Take it to the top. I don't know. I don't know what it was like in the 80s. Yeah. I assume they gave you a wedgie and maybe
that's it.
Popular media is to be believed. You got a swirly and sent on your way.
But then again, the high school I did go to went viral like 5 years ago when another kid like body slammed this other kid, and it was it was a rough school.
Rough and tumble, huh?
Yeah.
That's too bad.
What are you talking about, kid? You're still alive, aren't you?
The mean streets of Sydney.
Yep. Yep. Oh boy.
Well, Dave, I'm glad you made it.
Yeah, I made it.
Yeah.
Yep. I'm alive and I'm not in jail, so
Yep. Doing well. Doing well.
I'm a success story.
All right. Well, I'm going to be here for another hour or so, probably doing placements. I am still in resistors. I still have
still in resistors.
A ton of resistors. I had
a ton. There's hardly any on the board.
Oh, come on. I had 19 line items and some of them had 8. The 0 ohm there was 8 0 ohm resistors. Come on, that's you probably add this up here, but
I don't know how you're doing it, Chris. I don't.
It's just
the stamina of it.
I am a martyr if nothing else.
All right.
Oh, a crick in my neck. Yep.
Have fun.
See you next time. Bye.
Catch you next time.